So here we have the log of x plus the log of x plus 21 is equal to 2. Once again here, the big thing going on is that we need to combine the logs before we try and cancel them out. You cannot cancel out when there's a sum over here. So I'm going to go ahead and use the property that says you can combine the sum of two logs into a single log. Now I'm ready to get rid of the logs. Because there's no base, I'm assuming this is a common log, log base 10, which means I want to exponentiate with a base of 10 to get rid of it. Okay, so 10 to the log of x times x plus 21. The 10 to the power of the log will cancel out, and I'm just left with the x times x plus 21. And then 10 squared is 100. Again, be really careful about what's going in the power here. Sometimes I'll get 2 to the 10th instead of 10 squared, and that is not good. That doesn't work. So really think about the exponentiating step, even if you don't write it for me. Okay, I've turned this into a quadratic. It's not really helpful, this kind of partial factored form. Factored forms are only helpful if this thing is equal to 0. So I'm going to go ahead and multiply that x back in, and then set this whole thing equal to 0. Plus 21x minus 100. And I think once again I was nice to us. This is factorable. I know I'm not always that nice on your homework, so make sure that you remember that you can use a quadratic formula if needed. But here it looks like if I use a 25 times 4 to get the 100, I'll also be able to get the sum of 21x. So positive 25x minus 4x is 21x, which means x can either equal negative 25 or positive 4. We do have to double check, non-optional check. This was a log equation. Unlike the last one, it was exponential, so we didn't have the non-optional check. Negative 25 is looking like bad news right off the bat, so I'm going to throw that away. 4 is looking great. I can take the log of 4. I can take the log of 25. So x equals 4 is my one and only solution.